shaping customer insights and feedback into product direction, driving new growth, strategy, and implementation agendas that deliver real business results for Pure and Pure's customers. Prior to his career at Pure, Nathan led the North America Server Specialist Technology Organization for Hewlett Packard Enterprise, supporting $2 billion in annual revenue, and focused on cloud, hyperconverged, composable, and blade infrastructure products and services. Nathan has also held several other notable roles in the technology industry, including co-founder and chief architect of ColdStor Data, where he led the design, was awarded patents, and brought to market the world's first purpose-built for archive cloud storage service. Please join me in welcoming Nathan to the stage.
Well, thanks, everyone. That was a little terrifying. I didn't realize that entire thing would be read off. As much as I do enjoy talking about myself, that was a lot of material. Anyway, I know what many of you are already thinking, looking at this title slide. Actually, perhaps most of you, considering this is the financial services industry, and there's a lot of, certainly a lot of opinions and willingness to share your emotions, which is this is kind of a dim-witted rhetorical question. Is AI ready for financial services? I sure hope that the presentation goes somewhere else from here. Well, at the risk of lowering the bar even further, here's a second rhetorical question. Are financial services ready for AI? So now we have nowhere to go but up. What I mean by this is it seems like there's all of these use cases suddenly cropping up for which AI appears to be a great answer, or perhaps in some cases, the only answer, despite the relative lack of maturity of AI versus other technological solutions out there. Why is it that there are so many sudden use cases for which we're willing to and encouraged to apply AI? And I think a lot of the reason why is because we're kind of in this magical time where we're at this race to ubiquity, where there's just this maximum amount of experimentation and optimism. And as a part of that, AI is not new by any means. It's becoming practical. But at the same time, it's really kind of a wild west out there in terms of sustainable, static best practices that everybody can apply and rely upon. And so with that, there's this kind of temptation to go really big, right? Because it's right now when, if we make these investments and we're right in terms of our application of AI, the payoff can be the largest. We can have the greatest competitive advantage. We can separate ourselves from our peer competitors as far as possible. But it's also when the risk is the greatest, right? We have that initial investment can yield nothing. The results can be nothing. The results can be catastrophic. Even worse, they can be operationally damaging or reputationally damaging. So really, where do we go from here? Where are the right use cases for AI? And also, what are some of the best practices that we've been able to establish in this wild, wild west right now? So to kind of start off with some of the use cases, a lot of them really come from threats. So for example, how do we deal with the increasing amount of regulation, especially multinational regulation, especially penalties from regulation for multinational companies? Along with that, there's a lot of upstarts. A lot of low-cost capital is creating many new challengers to incumbents. For example, in the UK, there are I think 9 new banks known as neobanks that have emerged within the past 5 years alone. And if you look at the cohort of customers that are college-age adults, they're really establishing their lifetime brand preferences right now. Now, despite only being in the market for 5 years, 1 in 5 of those college-age adults uses a neobank as opposed to a more established bank. Perhaps an even greater threat is that of tech giants, right? Starting to dip their toes into the financial services industry, both things like Apple Pay and Facebook with cryptocurrency. But it's really more the possibility here, right? They have the financial war chest and the existing scale to get very big very quickly, to be ubiquitous in the consumer market very, very quickly if they choose to do so. And then finally, of course, is cybercrime. We're seeing this continuous exponential rise in cyber threats. And realizing that the linearity of human analysis and resolution, it's impossible for that to really be the solution to apply to this exponential rise. We have to use a technology like AI to be able to address the exponential rise of cybercrime. And so we're seeing this, IDC is forecasting in the next couple of years that over half of security alerts will be powered by AI automation. And actually a large percentage as well will have some automatic resolution due to AI automation. Perhaps the most exciting is that of enhancing the business. There's the obvious that we see a lot in the market of moving beyond high frequency trading, the AI applied models of the systematic quantitative investors for trading strategies, but also in the insurance market where new ability to analyze down to the individual consumer allows for these kind of bespoke policies, bespoke risk analysis of individual consumers. Things like, hey, if you can run a 9-minute mile, you get this additional life insurance discount. All this ability to, instead of have larger groups, take it down to individual decisions and price insurance as a result. And then, of course, finally, customer interaction. Both the ability to, we have a customer that sounds a little bit scary, but they monitor all of the calls coming into their call center. And they do it both to get essentially a synopsis of what happened for each call that they can go and look back on, get essentially an abstract of that call, but also monitor customer sentiment analysis. Is this one particular call center employee resulting in half of the customers are really unhappy? Or more positively, this person's a rock star and they're able to turn around customer sentiment within 5 minutes. Also, new routes to customer service. There's customers often feel that there's never enough customer service representatives, and so now AI-powered chatbots can get those customers some degree of resolution, perhaps faster sometimes than even a real human can. And this is, again, the key word here is ubiquity. We're seeing AI now in the next couple of years is going to power. Is at least going to be some component of the majority of AI of enterprise applications. More interesting than this, I think, is that if you look at the user interface for enterprise applications, about a third of those user interfaces will either be replaced by automation or by some sort of AI interface, similar to Alexa, as opposed to the existing screen-based user interface today. So with that, I wanted to share some insight from some early at-scale adopters that we've seen. So we had, a lot of the challenge is really that of finding those initial best practices that can help you be more successful with that initial bigger investment. And we have a lot of visibility into some bigger scale investments that have been made. We released the world's first AI converged infrastructure almost 2 years ago. And for example, as a data point, we're the platform that the majority of large self-driving car initiatives run on top of. So we've seen a lot of AI going big at scale early on, and a lot of just wonderful stories and a lot of horror stories as a result as well. So really the first one is that of, do you really need to go big? Is this something that you need to focus on right now? Are you using AI or potentially considering AI really for more of a tactical solution? And that's totally okay. In fact, that's potentially better than going big. If you realize that there's one specific use case or a handful of use cases that AI may apply to, but you're not really ready to create a corporate data strategy, an overall corporate AI initiative, it's okay to be tactical in pursuit of a specific outcome. But one of the lessons from that is whatever you do in developing that tactical solution may have little to no value in terms of going to a more strategic solution later. So be willing to essentially take some of the lessons from that initial use case, that initial experimentation, but also throw away what you did tactically because it may not service your strategic initiative later. Another thing, and this is certainly true in all applications, where you see this kind of divide between the infrastructure architects and the developers and the application architects. They're speaking different languages. They don't understand what each other are talking about, and that couldn't be more true for AI in particular. The data scientists have no idea what infrastructure, if any, the solution runs on top of, and the infrastructure architects don't really understand AI at all. So there needs to be some concerted effort to figure out how do you essentially get them all in the same room and apply that translation to allow them to work together and better understand what their shared goals are. And that's a big challenge for big organizations. Big organizations tend to be particularly siloed, and AI initiatives require everyone on board. They require so many different types of technologies, from container and Kubernetes experts to compute GPU CUDA experts to data scientists to network infrastructure experts. Again, many of whom have no idea what's happening outside of their silo, who don't understand what the objectives are of the overall AI initiative. So this is a huge challenge, and it's one that's based on the existing silos that many large organizations have, which also falls into the data itself. If you look at one of probably the most well-known AI luminary in the industry, Andrew Ng, he talks about this concept of how do you basically, to be successful at AI initiatives, you need to get as much of your data into a single place as possible. Unify your data into a centralized data warehouse, a centralized data hub. And the reason why isn't because of the infrastructure efficiencies. It's because if you have 10 different silos of data, your data scientists often have to go to the 10 different VPs that own those silos of data to get access to them and to be able to actually provide a solution and analyze across those silos. The other challenge, obviously, is that of where do you source the data? These are volumes of data that many organizations are not used to, and types of data that they're not used to, such as labeled data. The need to be successful with the volume and the type of data. Many organizations starting on this journey are unaware of the type of data and the amount of it that they need to really be successful. Also, don't be rigid about tools. Again, because it is the wild, wild west, there's a lot of temptation to go proprietary early on and get some initial advantage, something that gets you to market faster. But because the standards are changing so quickly, because the best practices are being established and thrown out the window so frequently, you need to make certain that you're able to change the parts on the car as it's moving down the road. You need to be able to have some flexibility to move in and out of your tool set. One of our customers said, the example is you don't want to be right for 6 months and then wrong for forever. You need to be able to have the flexibility to change going forward. And then actually testing this out. This is, if you're thinking about putting in a big investment into AI, there's naturally going to be some degree of a proof of concept phase. The challenge is, and I've seen this being at a manufacturer vendor, many customers are not particularly successful at their POCs. What they do in their proofs of concept don't actually correlate very much to their actual production environments and the success that they're looking for in their production environments. And a lot of that is really based on scale, right? It's very hard to take the synthetic workloads that you do at a small scale and hope that they apply to the big scale that you're going to do later. We also see architectures that naturally have some degree of envelope. There's things that. One of the problems, if you look at a lot of what proofs of concept do, is it's the assumption that a workload is going to behave linearly over time, and that's absolutely incorrect for almost all workloads, right? There's this kind of envelope of where they hit this knee in the curve, they go nonlinear, and suddenly the architecture that you had that worked fine reaches a stage where it doesn't work nearly as well, or it doesn't even work at all. So really figuring out where are those envelopes in your architecture, so you know the gates as to where you may have to make changes, and figuring that out in your proof of concept. And as much as possible, doing a proof of concept with real data at real scale. Really, toy data generates toy results. You want to be able to prove that it works with a real thing. And that means that there's often a significantly greater time investment in the proof of concept stage to make your actual production have a much greater chance of being successful. Another thing is that of documenting the key objectives for the infrastructure. And I know that for many of those who are firmly on the application and data scientist side of the house, who cares about infrastructure that much? But these actually can set up some great, really axioms within your infrastructure that can ensure that you're ready for processing the next set of data. And typically, kind of the two axioms that we see are you want to keep your GPUs busy. They're extremely expensive. And you want to keep your data scientists busy on the right things. They're also extremely expensive, and they shouldn't be doing systems tuning. They shouldn't be idle. You want to keep these two highly priced resources as busy as possible on the right things. And so with that, if you're doing, for example, a proof of concept or you're doing a business case, you're going to want to make certain that you're including these elements in that business case and the total cost of ownership. So you can make certain that you're looking at data scientist productivity in your infrastructure evaluation. And then obviously recognizing the cost of data scientist specialists. This is, perhaps more than anything else, what you should be designing your infrastructure around. These are both from a cost per effective, labor cost per hour, but also given how limited the pool is of data scientists, you want to keep them busy, you want to keep them happy, and if they can't essentially do the work that they love because they're waiting on infrastructure, that can be a challenge to retention in addition to actually getting a good TCO out of your group. And finally, what we've seen universally in the self-driving car manufacturers, but also beyond that, is that AI is a pipeline. It's effectively like a CI/CD pipeline for development. And how do you look at this pipeline across the entirety of it and maximize the efficiency of that pipeline? What we have seen in those self-driving car companies is they have virtually all moved from one model that you see here, which is these kind of 4 stages of the AI pipeline, from ingest to clean and transform to explore to train. And the challenge is that these are entirely separate silos. And if you look at the infrastructure objective of making certain that your data scientists and your GPUs are maximally used, these intermediary steps of copy and transform are just tons of idle time. There are tons of time where silicon and people are twiddling their thumbs because they're waiting for data to move from one place to the other. It's an incredibly inefficient approach, but it's one that we found virtually everybody started with. So essentially they all move to this approach here, where they essentially have one data plane, they have one essentially data store across all of their AI pipeline. So there's no longer the need to do this significant copy and transform event. They can essentially either immediately gain access to the data or virtually move it from one silo to another because it all sits in the same place. This has radically improved their time to market and their time to iterate through their AI pipeline. And I think it's fundamentally the one thing that customers that are looking to be successful at scale and need to think about when they're building their foundation. It ties into what I mentioned Andrew Ng said, you need to find one place for your data in order to be successful at AI. You need to unify your data into a centralized data hub because you need to, both from an organizational perspective, limit the silos, but also just from an infrastructure efficiency perspective. And so if I could ask you to take one thing away from this, it's that look at your own initiatives, your own infrastructures. How much are they bespoke and siloed today? You want to make certain that you can move away from that bespoke siloed approach into a kind of a mass production pipeline approach. This is something that Henry Ford solved 100 years ago and created essentially the third industrial revolution. And I think we all have to solve it here and for the fourth industrial revolution with AI to get that massive production out of a single pipeline, move away from silos, move into a unified data structure. And with that, and with my 4 minutes and 30 seconds left, thanks everyone for coming today. I hope this was helpful, and I'll see you out in the lobby.
Thank you so much, Nathan.